I still remember the day I saw a self-driving car navigate through the crowded streets of Bangalore. It was 2019, and I was blown away by the fact that a machine could make decisions in real time, avoiding pedestrians, cars, and even potholes. The company behind this tech claimed it was using a combination of AI and ML to make this possible, but I had no idea what that really meant. I mean, weren't AI and ML just buzzwords thrown around by tech enthusiasts? But as I started digging deeper, I realized that these technologies are not just buzzwords. They're actually changing the way we live and work. So, let's start with the basics. What is AI, and how is it different from ML? AI, or artificial intelligence, refers to the ability of a machine to perform tasks that would typically require human intelligence, such as learning, problem-solving, and decision-making. On the other hand, ML, or machine learning, is a subset of AI that focuses on the development of algorithms and statistical models that enable machines to learn from data without being explicitly programmed. Think of it like this: AI is the broader goal, while ML is one of the key techniques used to achieve that goal. Now, you might be wondering, how do these algorithms actually learn from data? Well, it's quite fascinating. Imagine you're trying to teach a child to recognize different types of animals. You'd show them pictures of dogs, cats, birds, and so on, and each time, you'd tell them what animal it is. Over time, the child would start to recognize patterns and features that are unique to each animal, and they'd be able to make predictions about new animals they've never seen before. ML algorithms work in a similar way. They're trained on vast amounts of data, which allows them to identify patterns and relationships that might not be immediately apparent to humans. But here's the thing: the quality of the data is crucial. If the data is biased, incomplete, or inaccurate, the algorithm will learn from that and make predictions that are also biased, incomplete, or inaccurate. For instance, if you're training an algorithm to recognize faces, but your dataset is predominantly composed of white faces, it's likely to struggle with recognizing faces from other ethnicities. This is a problem that many companies are grappling with. And it's not just limited to face recognition. It's a challenge that affects many areas of ML, from language processing to predictive modeling. As I dug deeper, I realized that the process of developing and training ML models is incredibly complex. It involves a range of techniques, from data pre-processing to model selection, and it requires a deep understanding of both the data and the problem you're trying to solve. But that was not the real problem. The real problem was that many companies were using ML without really understanding how it worked or what the limitations were. They'd throw a bunch of data at an algorithm, hope for the best, and then be surprised when it didn't work as expected. I spoke to a friend who works in the tech industry, and he told me about a project they'd worked on, where they'd used ML to predict customer churn. They'd collected a ton of data, thrown it at an algorithm, and then waited for the results. But when they got the results, they realized that the algorithm was predicting churn based on factors that didn't make sense. It was essentially finding correlations that weren't really there. They had to go back to the drawing board, re-examine their data, and retrain their model. It was a costly and time-consuming process, but it taught them a valuable lesson: that ML is not a magic bullet. It's a tool that requires careful consideration and expertise. Another challenge with ML is explainability. It's often difficult to understand why a particular decision was made or what factors contributed to it. This is a problem that's being researched extensively because in many areas, such as